This will be a quick video showing how we can use the sum and difference identities to help prove other identities. For example, if I gave you a question such as prove sine of alpha plus beta minus sine of alpha minus beta equals 2 cosine alpha sine beta, we're going to remember, since we're not sure if this is equal, we can't use our additive property or multiplicative properties of equality. But what I can do in this case is, if I see a sine alpha plus beta, I can go back to my sum and difference identities and recall what the identity was for sine of alpha plus beta and sine of alpha minus beta. And first I'll take the sine alpha plus beta and substitute it with sine alpha cosine beta plus cosine alpha sine beta. And next I'm going to substitute sine alpha minus beta with sine alpha cosine beta minus cosine alpha sine beta. And since sine alpha minus beta is subtracted from sine alpha plus beta, we need to make sure we remember to use the distributive property. So I end up with sine alpha cosine beta plus cosine alpha sine beta minus sine alpha cosine beta plus cosine alpha sine beta. Well, if I look at this, I see that I have a sine alpha cosine beta and a negative sine alpha cosine beta. If I add those two together, they equal 0, and I'm left with cosine alpha sine beta plus cosine alpha sine beta. And is that equal to 2 cosine alpha sine beta? Well, if I combine those two terms on my left-hand side, I find out that yes, indeed, 2 cosine alpha sine beta equals 2 cosine alpha sine beta. So I have proven this identity. This is just one example of how we can use the sum and difference identities to help prove other identities.